So first thing first. So the thing is with the companies, what you need to understand is how data inflows into your system, and how then you try to get the entire data all together in a data frame, and then do the post processing of the data. And in terms of like machine learning concept, it's like pre-processing of the data. So whatever data you clean and prepare before applying it to a machine learning model, that is called pre-processing of data. And whatever results that you have got after the prediction, and if you still need to manipulate the prediction or any sorts of data, that's called post-processing. Okay, so we'll learn the pre-processing part today. And the most of the questions that are aligned with the data cleaning and EDA are mostly related to how we got the data, what were the sources of the data. So first thing first, you'll never say that there was just one source of data. There, if you're working with a company, there are multiple data sources, as you might be aware. There could be direct their SQL server, any SQL server from where you could get data. There could be a legacy system from where you could get data. There could be a third-party data providing company that your company is paying or client is paying, and you get data from there as well. So it could be multiple data sources from Kafka live data. Yeah, and some live data as well. So if you're mostly working in a dynamic scenario where you don't have to generate a report after the entire prediction, and if you have to just do dynamic reporting or something like that, then obviously live data coming from cloud environment as well. Can we please list some example? Okay, so example. So I'm telling you an example of one of the retail company that I was working with, and they were having data related to their sales. Okay, and so their sales data used to come directly from their own SQL server. Okay, so when I'm talking about the sales data, it strictly confined between the UID, that was like a unique identifier of each of their customers, and then what was the sales that they gave in the previous months, and also what sort of products that they bought, also what was the basically the products and the price of those individual products. These sort of information we got from directly the SQL server of the company. The legacy system told about the inventory of the data. So if at all the customers, when I'm talking about the customers here, I'm talking about a huge company, a multinational company, dealing directly with their distributors and retailers. So their distributors and their retailers were their customers, basically. And the legacy system used to tell about the stock of the data, like what is the inventory as of now, what is going to, how much stock of particular product is available, and things like that. Okay, so stock, inventory, and total addressable market used to come from their legacy system. And then there was a third party company which provided the market level research data. So the third party company used to provide the GDP, the market share, and like the condition of the economy, and like the mean salary of the population of that particular area, and things like that. So why these all factors help to build a machine learning model? I'll tell you an example. So direct influencers are obviously your previous sales data, okay, because you are trying to predict sales. Okay, so direct influencers. So some main, obviously those main variables, those important variables would be your previous sales. Okay, if you want to check the inventory and stocks, then obviously those information also help, and that comes from legacy system, because it has been maintained from like a very longer period of time. Okay, and then when you want to judge the future of a particular customer, like whether a particular customer, suppose belonging to a region in London, okay, and a particular customer belonging to a region in say any part of Africa, they won't be having same sort of sales first, and they won't be having same sort of economical background as well. So the external factors like GDP, the total addressable market, and the factors like what is the average salary of people in that population in that area, these factors also come into picture when you try to give an accurate prediction of sales in the future. Okay, so this could be one of the example. This is a practical example that I worked on, and you can share this example with in your interviews, and nobody will ask you any question further. Okay, so so this is one of the example that tells you about that only if you're predicting something, predicting a sales revenue or something, only the sales factor and only the inventory or stock factor does not come into picture. There are other external factors, multiple variables like 30, 40 odd variables that can come into picture and play a role in it. Okay, sometimes even these do not play a vital role in prediction. So you have to generate new variables. So that's called feature engineering to improve your prediction and things like that. Okay, so make sure that you don't say anything which does not make sense. So what I'm trying to convey is like it is all making sense right now. So make sure whatever project you are conveying to the interviewer, they all make sense and your data is related to that. Okay, and don't talk about like diabetes detection and cancer detection and things like that. It's good for your knowledge, and it's good for your project as of like showing that you have done something academically but not with your work experience. Okay, in terms of NLP and sentiment analysis, we'll obviously talk about that maybe tomorrow or maybe after a project session. I will let you know, or like management team will let you know. Today, for now, we will strictly discuss about the EDN insights from retail data, as you can see the topic. Okay, the objective today would be to perform EDA to find out how many customers are actually satisfied with the products and services provided by retail company. Okay, for this, you need to understand data. Okay, so I'll go to the Excel sheet that I have. Okay, so you can see this is the data that we are. Can you please unmute me? Okay, I will unmute you all.
Hello.
Hi. Can you hear me?
Yes, yes, I can hear. So my question is, this is the example what you have provided was related to the retail industry. And can you please provide more examples like related to the healthcare domain?
Healthcare domain. Yeah, obviously. So healthcare domain is basically, suppose, so I did a project in healthcare domain. So I'm just sharing my experience, just sharing my practical experience with you guys. Okay. So in healthcare domain, when I was doing a project for a company, it was a company from Brazil, and so it's a very long chain of hospitals managed by private investors and government over there. Okay, so there people used to have problems like above the age of 60. People used to have problems like whether they are eligible for like the patients above 60 or above 50 age plus, like old age patients, whether they are eligible for an operation or not. Okay, so with those factors like their blood consistency, their bone condition, their uh, like condition of heart, their condition of skin, their condition of lungs, these factors play into picture directly, like about a patient's eligibility criteria for a basic operation, whether they would be able to survive that operation or not. Okay, so that comes directly from the patient's history. Okay, apart from that, there are other medical records that they collect altogether to provide information to analytics team, so that they would be accurately able to predict whether these factors also play a role for their eligibility in the operation or not. So those factors are basically their previous health record, like whether they have been operated previously or not, what are their medical condition based on their medication. So how many medicines do they take, which type of disease that they are already going through. Okay, these sort of information. So one of the data source in the healthcare domain could be directly data coming from the patients, like, okay, and the other could be the data that has already been collected by multiple hospitals. Okay. And that information is provided. So unlike in India, most of the North American, South American, and European countries, they have a particular number, okay, that insurance number that is assigned to each and every person, okay, and that number
Like
is
Medicaid ID?
Medicare ID, or you can say insurance ID. I mean, whatever, just an ID. It's an identifier which can help the government officials and hospital chains to identify and track all the record of the patients. Okay, so one information can directly come from the patient. Okay, that's why they gave the form before an operation, that like what are their medical condition, and the other could be checking their background. Okay, so that comes from directly from that legacy system, which gives you a central record of the entire data of what they have for the customer. Okay, now it becomes a bit challenging when the customer has migrated into the country and then they are checking whether they are eligible or not. Okay, so in those cases, you will find multiple patient information missing. So in those cases, it becomes a bit challenging, and you strictly have to restrict your information to the customer, to the information that the patients have provided. Okay, but in most of the cases, 70% of the cases, or even 80% of the cases, they will have two different systems, one information directly coming from the patient, and the other one coming from the legacy system, a record that the entire country's hospitals maintain. Okay, so this could be an example of the healthcare domain.
Rahul, we can include toxicology also, no? Toxicology related data also, no?
Toxicology related data, uh, when I was doing this, it was not provided to me, but yeah, it could be related to the GDPR issue. So not every sort of data is openly available to you. That's also a thing. You should keep this in mind, that not every sort of data will be available to you. So suppose if a patient is not willing to confess something, or willing to openly talk about some information that they have, some problems that they have, you cannot just basically get it out from them. So those sort of information, if they have mentioned to some authorities that this should not go out, it won't go out, it won't come to you. So that sort of problem. So sometimes you'll get that information from few countries, sometimes you won't. So that's completely optional, but these two things are always available, these two information from two different sources. Okay.
Rahul, I have one question. How basically you are getting the data from these sources? Like, are you getting the data in the form of CSV or directly fetching the data from databases? What are the databases involved? So these kind of things I want to know.
So it depends, Rupesh. So basically what happens is, it depends on the company, it depends on the client, it depends on the infrastructure that they have. So sometimes you will see that companies are still working through CSV files. So they will give you multiple CSV files, and it will be your job to just merge each and every CSV file data into one data frame and then start working on it. Okay, so that's up to them. They might share it with you on a drive, or they might share it with your with their own SharePoint, giving you some access. Okay, that could be one thing. Depends on the size of the data, and depends on the infrastructure that they're following. Okay, if they already have a cloud platform in place, then they obviously just give you the access of that cloud platform. Okay, and that cloud platform will contain multiple tables. Okay, just like you see in a SQL server as well, there are multiple tables similar to that SQL server. There would be a cloud platform which will have multiple tables, and you will have access to specific tables from that cloud platform. Talking about taking an example of GCP. Okay, Google Cloud Platform. So Google Cloud Platforms are very simple. So they suppose there are, in the left hand side, there are multiple tables, and you are getting access of those 5 tables. So just need to write SQL query, okay, in the GCP BigQuery, and then extract data, and then that data basically you can observe in the same table. Okay, and if you want to manipulate, you can use BigQuery to manipulate that data. And then if you're satisfied with it, you either can pick up few columns of that data from the table, or you can get the entire data loaded into your Python notebook. Maybe it could be Jupyter, maybe it could be VS, maybe it could be the same platform say suppose your GCP is connected with Databricks, okay, and Databricks gives you the opportunity to write Python code, Scala code, R code, everything. So you can just directly write the path and get the data from that GCP server, and basically ingest all the data and get and start your work. Okay, getting all the data into a data frame. So that's how it works.
Rahul, I have one more query. For example, what is the maximum limit of any live data which is stored in Kafka or Azure Streamlit?
It depends. It depends. So there's no maximum limit to it. So basically, what happens is if it is a live data, it is coming directly to your server. So it depends, like what is the length of the data. So matrix wise, how many rows and columns are present, and basically it also TTL, yeah, and it also depends on the purchasing of that company. So suppose the company has purchased up to a limit, then obviously it will be limited to that particular memory space of the data. If they have just subscribed as pay as you go kind of subscription, then obviously you will the data that will be coming to them, like live data, that will be just ingested, and it will be ready for processing. The problem here is not about the limitation of the data. The problem is the speed through which the data is being processed. So sometimes when you'll see, so there's a company, I'll give you an example. So there's a company that manages the bus transaction of entire UK. So there's just one payment company that manages the bus transaction of the entire company. Okay. And their data basically can come through any cloud platform, not only GCP or whatever. Okay. So that live data, each and every hour, it generates a live data, which is like huge. So every time a customer is tapping in and tapping out in the bus through card, their transaction ID is generated, and every time it gets processed. Okay. So
like in that sample data, for example, in the live data, we are going to take sample data. No, how much size of the data we are going to check in our local. So one thing is like we can directly connect to the SageMaker or ML Studio. So instead of that, if you want to check, like if you want to visualize or anything, so in the live data, how much MB or GB of that data we can consume, and we can do the EDA or ML side, ML flow.
So if you're talking about sample of the data, okay,
Yeah.
it completely depends on the size of the data that you have. So suppose if you have like 100 GB of data, okay, and if you are comfortable doing some statistical analysis on 1 GB of the data as well, and taking multiple samples of that data, that is the best practice that you can do. Okay, so 100 GB of the data is there. Like you take a sample of something between 1 to 5 GB of the data, and then take multiple random samples and then do testing. Okay, and then take the average mean or average standard deviation or whatever, and then if you want to find out some information about the entire data, then with some confidence interval you can say that, yeah, I'm 90%, 95% confidence that this data would be following this particular pattern or this particular mean or this particular standard deviation and things like that. Okay, so it completely depends on the entire population, and then it depends on you as like what sort of sample size you want to take, and how many sample size you want to take, and how many iterations you want to perform. Okay, it does not have a fixed answer, unfortunately.
Okay, it was asked in my interview, so that
Okay, so you cannot say a fixed answer to it. So you just have to mention that, yeah, obviously it depends on the size of the population, and then it depends on the number of iterations that I want to perform to confidently say whether I'm 90% confident or 95% confident or 100 or not. 100% is not a viable answer anyway. So 90% confident or 95% confident whether this particular entire population is following a pattern or not, because and you can say that if there is 100 GB data, then any sample between 1 to 5 GB would, and at least taking 5 different sample size to samples basically to perform EDA, perform statistical analysis would be good. Okay. Yeah, Strata will also work in large data. Yeah, exactly. Okay, so already like around 40 minutes have passed and we haven't started the lecture. So let's get back to EDA first. Okay. So this is about EDA of retail company. Okay. And as I talked about the EDA, we are trying to find out these products and services that are provided by the retail company, whether customers are satisfied or not. Okay, so that's the objective of our EDA. Okay, and this is the data that has been provided to us. Okay, it's a very small data, but the main objective is that we are going to learn from it, and the same things can be performed on a larger data set as well. Okay, so that's not a problem. Okay, so it contains order ID, customer ID, and then it contains the date. It contains nearest warehouse. So there are maybe multiple warehouses where their product and services are provided, not services, basically products are provided. And then there's a shopping cart information where whether through multiple platforms, whether the shopping is basically done. So basically maybe it could be any product that they have bought. Okay, and there could be multiple shopping carts for one customer as well, and there could be multiple products in a shopping cart as well, and there could be just one product. So it depends on the customer. Okay, then there is order price, and then there is delivery charges, and this is customer latitude and longitude, which gives you the location of the customers. Okay, so sometimes they don't want to, and this is because of the GDPR issue, they don't want to provide any direct information. So maybe they'll provide latitude and longitude of the customers, okay, not the address to you to do the analysis. And maybe that's a good thing. And even in those latitude and longitude, these information could be encrypted. Okay. And then you have a coupon discount column where like some customers are provided some sort of discount, 10%, 15%, 25%, things like that. And then there is the order total, and then there's a season which describes that in which season these orders were made, just to give you further analysis. Okay, and basically and then there's a delivery information, and then there's a distance to the nearest warehouse, at how near, I mean, which person is falling into which zone, so that the nearest warehouse can provide the basic, the nearest and fastest delivery services. Okay, and then there's the customer review, and obviously then there's a binomial information that you have, like whether the customer was happy or not. Okay, so it's true and false. Okay, so that being said about the data, let's go and check what we can do with this data. So first thing first, we will basically try to import the libraries. Okay, so we'll import all the libraries. So I'm importing OS, NumPy, Pandas, Matplotlib, and Seaborn. Okay, then we'll read the data. Okay, so when you read the data, you will see that the same information that we saw in the Excel sheet that has come up. Okay, so this is pretty basic, and this you all must know as well. Okay, now we want to get the description of the data. Okay, and the description of the data says a lot about the data itself. Okay, first thing, it will give you all the numerical variables that are present. Okay, so apart from these multiple variables that we have, 12 variables probably, we only have 6 variables which are having numeric data. Okay, so order price, delivery charges, customer latitude, customer longitude, coupon discount, and distance to nearest warehouse. Okay, gives you count, mean, standard deviation, minimum value, maximum value, and 25th percentile, 50th, 75th percentile. Okay, for a data scientist, this information is enough to understand the presence of outliers, for presence of the median value, and obviously it gives some feeling that whether that particular variable might be having an outlier or not. So maybe if we check the order price, maybe it might be having some outliers, because 75th percentile shows 20,360 as the 75th percentile value, but you can say that the maximum value that is coming is 9,47,691, which is pretty huge. Maybe it should have ended at 30,000 something, but it is going to 9 lakh. So you can say that it is an outlier. Okay. Same goes for 25th percentile and minimum value in this order price. You can say that minimum value over here, 585, could be an outlier. Okay. So just gives you an indication whether you would want to check this particular column in future or not. Okay. And when you see other variables could or could not be having outliers. Okay. But again, you have to, if in my first instincts, what I will do is like, I will just check the order price first. In the distance to the nearest warehouse, this could be another variable which might be having outlier, considering this particular variable value is much higher than 1.40. Okay. But yeah, it depends. So first thing first, we'll check the shape of the data. So 500 rows and 16 columns. Okay. The next step would be to check the null values. Okay. So just a minute. So I'm checking the null values. So what you can see here is like when I'm checking for the null values, I'm checking the sum for each and every row which is containing null. Okay, so order ID does not have, the other variables do not have, but order price is having 2 rows which are null. Delivery charges has 4 rows which are having null data, and is happy customer, which is a binary information, true or false. 4 of them are missing as well. Okay. Now this is just an example because the number of rows are 500, and basically what will happen is in a real time data, it will be like thousands and millions of rows, and there could be 10 to 20% rows that will be having missing information. Okay. But the same sort of code, the same sort of concept can be applied to find out the missing values, and then operate on that. Okay. So you don't have to worry about, changing anything. You can directly take the code, directly take this concept all together and perform the same EDA in your larger data set as well. Okay. For minimizing the processing time and for the simplicity of explaining, I've just taken a smaller data set. That's all. Okay. So now that we have checked the null values, what will happen here is basically I want to find out whether there are outliers present or not. I can check through box plot, obviously, and it's just not a particular value that I want to find out. I just want to check the presence of the outlier. So box plot can basically tell you about whether there is an outlier present in a particular column or not. Okay, so simply I'll run this code. I'll just explain the code. What is happening here is I'm just trying to I've imported a library, matplotlib, okay, and plt is the alias name. So I'm just trying to use that to give the figure size, and then I'm doing the plotting a box plot, and the columns that I'm giving here is delivery charges and order price, because I want to check whether the order price and delivery charges column have outliers or not, so that I would be able to replace these null values accordingly. Okay. Now, when you see I haven't taken is happy customer, it's because we cannot perform a box plot on a variable which is having just 2 information, true or false, binary data, and only and that won't give you any outlier as well. So suppose if a column has just 0 and 1, then there are two values, 0 and 1. There won't be any outlier in that. So there's no point plotting a box plot for a variable which is having just true and false information, as you can see. Okay. So first thing is like you have to observe the data simply as well. So by the looks of it, how it looks, what are the variables, what could be the data types and things like that. Okay. Now, when you do the box plot, when you plot it, you can see that delivery charges are basically pretty much, normally distributed. There are no values which can be considered as outlier. But in order price, you can see there are multiple outliers. If you want to increase the size, say suppose I just do 20, and you can see delivery charges are absolutely okay. But in order price, basically there are multiple outliers which are coming. Okay. So this gives us information that there are multiple outliers present in order price column. And if we are to, replace those null values, then we have to check whether we can do it by mean, we can do it by median. Okay. So what do you think in case of delivery charges and order price? They both are having some null values. In case of delivery charges, what would be the ideal replacement value? Can anyone answer?
Median.
Median or mode?
Delivery charges, median or mode? Yes, Santosh.
Mean.
The answer would be mean. Okay. As there's no outlier, we don't need a median. And as there's no outlier, median and mean would be same, exactly the same. But again, it could be different. Okay. If it is not normally distributed. So right now we can assume that it is normally distributed because everything is coming all together. But there could be a case there it could be slightly right or left skewed. So the safest option would be mean in this case because there are no outlier present. And what about the order price?
Median.
Yes, because it has almost plenty of outliers. Okay, so the best would be to replace it with a positional average value. Okay, so median. And what I can say in this case is those who answered mode, for them, mode is only used when you have a categorical variable. Okay, so here true and false are categorical. This happy customer is a categorical variable because it has just two options, true or false. So we cannot, and the other ones like order price and delivery charges, basically they are basically numerical variables. So basically you can't, these integer types are basically multiple, like they are continuous variables. They do not need a mode to be replaced with. Okay, so never do that. So as you guys answered, most of you answered correctly. I would replace the delivery charges with mean because it does not have any outlier. So as you can see, I'm just taking the entire data into an object named dirty data, and delivery charge is my column name. I'm just filling the NA. Fill NA is basically a function which helps you to identify the null values. Okay. And then I'm taking the dirty data information, and then I'm replacing these values, the fill and the NA values, the null values, basically with the mean of delivery charges column. Okay. And in place is equal to true is very important because this will be helpful in replacing the data. If you don't do this, then when you go to the next step, this information would be invalid. So this whatever replacement you have done would be invalid. Okay. Now when you do dirty data order price, then you can see that fill NA, replacing it with median because it has multiple outliers. Okay. So I'll just replace it with median. Okay, that's done. And now when I talk about the happy customer data that we have, basically there's four null values. Now what I'm doing is I'm replacing it with mode. In this case, okay, there are two things, and as a data scientist, you have to understand whether that variable means something or not. So you have to be very, very peculiar about the data. Okay, so right now I'm just replacing it with mode because there are only four missing rows, and even if I mark it as true or false according to the mode, then obviously it won't matter much. But in case of categorical variable where you are having missing values around 10 to 20%, okay, you can see some influential factors as well. Okay, you can obviously in this case you can see that there is happy customer true and false, but there's a review as well, so latest customer review. Okay, so in cases where we are replacing the data, you have to take care whether customer review, how the customer review was, whether they are happy about it. So as you can see, I'll take the example of true and false here. 5-star, this is a great cheap phone, true. Okay, charger did not fit, charger don't fit, so it's false. So it's not, the customer is not happy about it. So even though there could be a case where like most of the customers are happy with the service, and I'm replacing it with mode, and right now I'm just replacing only four rows, then it's fine. If at all there is a case where there are multiple customers which are not happy about it, and I'm just replacing them with true and their review says something else, that could be a problem. So in those cases you have to do it, you have to perform manually, or either manually, or you have to do a sentiment analysis, in which we are not going to go right now. And you just have to do a sentiment analysis on this particular column, okay, latest customer review, and then find out whether the sentiment of that particular comment is positive or negative, and accordingly you have to do the data imputation. Okay, understood?
Rahul, I have one question.
Yeah.
Like here, the missing percentage is very less in the input variables.
Yep.
So if the input variables are containing approx 8%, 9% missing data, then what will be our approach?
So up to 10%, you can just, I would say between 5 to 10%, you can, or 0 to 10%, you can simply, in most of the cases, if the customer is happy about it as well, you can simply just replace it with mode in this case, or mean or average value, mean or median, okay, accordingly. But in case where like it exceeds more than 10%, okay, and solely depends on the customer, so solely depends on the business problem as well, okay. If this particular variable is very important to them, they would ask to do data imputation very precisely, okay. So that's why when we do EDA and we do data cleaning, it takes a lot of time. Sometimes it takes more than a month to perform this, okay. So it depends on
If delivery charges is taking more than you can say 10% null values, then what will be, then how can we resolve that part? Delivery charges or order price, these are containing 10% or 15% null values.
Okay, so there could be multiple ways to do it, okay. So in this case, you can simply replace it with, the data is not good enough, it seems clean data, seems clean data. What do you mean, Praveen? Sorry.
Like what we encountered is basically a lot of nulls, not of invalid values. Okay, lot of, not even the values are not homogeneous. Say for example, if some are integer, some they have filled with categorical. So much of the destructions in the data, what I have seen till date in the industries. This data seems very good.
This data seems very good, I understand.
Yes.
But hold on for a while. It does have all the problems that you're talking about, and you just have to wait.
Okay, fine.
There could be fewer examples than what you have encountered in the industry. But the thing is, if you do it for a smaller data, you would be able to do it for a larger data as well with the exact same process. That's the point. Okay.
Okay. Cool. Okay.
Okay, so coming back to your question, Rupesh. So if it contains more than 10%, and suppose it is a numerical variable, then you have to draw a normal distribution curve and see if at all it is following any pattern or not. Okay, then you might have to check the seasonality of the data as well sometimes, in some cases, and see whether the imputation could be best fit by just replacing the missing values with mean, median, or for if at all the data is following any cyclic pattern. So suppose delivery charges are increased in conditions where like there are a lot of traffic. So suppose the delivery charges could be very high in cases where there is some discount going on and people are purchasing a lot. So in those cases, in those seasonal times, okay, the delivery charges could go up. So you have to check in those cases the time of the order, date of the order, and then the distance of that order as well, and then do the imputation. But those cases are like exceptions, okay. And in those cases, you have to figure out the pattern of the data altogether. If at all it's not the case, then you can simply replace it with the statistical values, mean, median, mode. Okay, depends.
Rahul, I have one question. How can we check that the missing values are missing completely at random or not missing completely at random? What is the what is the procedure to check that?
Random as in, I mean, okay, it has been so most of the missing data could be random. So I mean, mostly it would be random. There's no pattern that a missing data follows. Okay, if at all a missing data is following some sort of pattern, then it could be a problem with the data engineering team. Okay, so suppose they have not ingested the data properly for a particular customer, for a particular region or something like that. But mostly it would be like The missing data could be because of the randomly data has not been entered, or somebody missed to enter the data, things like that. So in those cases, like if your objective is to find out, prepare your data for a machine learning model, it should be precisely, it should come into a normal distribution curve. So in that case, what your objective is to replace those values with an average value, so that it all comes together in a normal distribution curve and you would be able to process the data. Okay. Then again, it could be misleading to the misleading information to the machine learning model, could be, but still it's better than to randomly fill out the information. There could be some cases where you have to like figure out whether the median value that or mean value that through which you have replaced the null values with to whether they are itself contributing a lot to that normal distribution curve or not. In that case also, you have to see whether the replacement that you have done in the previous value or the next value, whether they are pretty much similar or not. So suppose I am replacing this delivery charge. Suppose I'm this particular bit, 65 rupees 87 paise. Basically, if I'm just replacing this value, okay, with a median value, I should see whether it is aligning to this particular numbers or not. So the previous one and the next record. If it is not aligning to it, then also it's a problem. Okay, so you have to figure out these things as well. So the best way to do it, if there are like more than 10% of the data, you have to put down a column, okay, and mark it whether you have replaced it with median or not, those variables, and just do a sanity check that what is their sum, if that sum, and take a sample of the information from that particular column, okay, and check whether the mean value of that particular column, a sample of that particular column, is very much in line with what you have done the replacement or imputation with. So those sanity checks also you can do, but if at all, but only if the data is used and more than 10% imputation if you want to do. But if it is less than, mostly it should be fine.
Okay, this type of analysis are we going to take in this project class?
Not today, okay, but because right now the objective is to like clear the basics first,
Sure.
and, cover all the aspects first, and then we can talk about those things. Okay.
Okay.
Rahul, one question on this part as well. Like using the KNN imputer or these kind of algorithms can be used for these kind of scenarios when we have multiple percentage of missing data?
You can, Rupesh, but depends on the other variables. So you cannot do KNN imputation just on that, just using that particular variable. Okay. If you do it, it would be highly influential. It would be very much similar to you replacing the values with mean and median. Suppose KNN, if you go conceptually, KNN obviously tries to find out the the central value, the mean value, and then tries to find, then calculates the distance between multiple data points, and then gives you a mathematical calculation using mathematical value using Euclidean method or Chebyshev method, whatever. Okay, and then gives you the final value anyways. So that could be very, very close to median or mean value anyway. So it depends. But if at all my delivery chart, suppose this particular column is highly influenced by order price or say suppose coupon discount or things like that, then you can obviously use the machine learning models to do the imputation. Okay, but again,
when there is a dependency.
yeah, obviously, but that's a costly process. I mean, okay. So these are some of the things that you can obviously say if an interviewer tries to screw you a lot in these sort of things, but obviously you must not say it in a very 100% certain manner, because nothing is certain here, obviously. Okay, depends on the business situation, depends on the data, everything. Okay, so as you can see there, the order price column has outliers, so we have replaced it with the median, and then delivery charges does not have outliers, so we'll replace it with mean. Okay, now dirty data that we have, now we are replacing it with mode, and here you can see that we have just replaced it with mean, median, and here we have replaced it with mode because it is a categorical variable. But again, apart from the in place is equal to true. There's one change in this code, and this is the thing. Like I've imputed this particular thing 0. So an index value. So basically, can anyone tell me why I have used this 0 in this case? Why not? And I need to run it. But why not just simply mean and median like that? If you are like familiar with the concepts of Python, how mode works, you would be able to answer. Can anyone tell me?
Yeah, because of the string.
Because of the string. Okay, yeah, close.
I have an answer. So it's because the two values have the same frequency, then it will select one value.
Exactly. Not exactly, but yeah, you're almost correct. So what happens here is mode. Somebody answered on the text. Let's see. Binomial, bimodal, or multimodal. Yeah, you all are going through the same thing, but the clear-cut explanation would be, so what happens is mode or median, mode basically is a function which returns series of the data. Okay, so if it is like true, false, or neutral, whatever, okay, 0, 1, 2, 3, okay, it will always consider true as 0, 1 as false, or things like that. Okay, so basically what happens is mode returns a series of data, and mode always gives the priority to the highest frequency information that it gets. Okay, so it will have the maximum value information like true and false. Okay, if it is the mode is true, basically it will return true, and then if the second most frequent value is false, then it will return false. So that's why it's important to give an index position. So this basically is an index position. So whatever would be the most frequent value in that particular column, in this particular column, we are replacing that with the null values that we have. Okay, so that's why this 0 is given, because we are now replacing it with the value which is the actual mode, but mode as a function will return a series of the data which is having the frequency of the information that we are trying to fetch. First frequency, exactly. Okay,
Can you
so
run that particular command that is present in the fill NA in the next cell?
this one in Excel.
In the next cell. Next cell.
Okay, next cell.
Yeah.
What do you want me to return? Right, sorry.
Inside that fill NA, only that command, like from the T data to mode of 0.
Okay, it won't return. It will give you an error. Let me just show it to you.
Not
Now-
complete command, I guess only the inner part. Like from fill NA dirty data is happy customer dot mode of 0 only.
Mode of 0 only.
Yes,
So you
yes.
want like this. So now that we replaced it, it won't make sense.
I think he just want to know the result, what we are getting by
Inner command.
yes.
Hold on. This we have done. Okay. If I do the mean, it's fine. If I do the median, it's fine. Now, if I do this,
Not this, only that part. In inner part of fill NA function.
Around just want to see the series of the mode.
you want to get it in a variable, say XYZ.
Just not in a variable, just simply print that part. We can also remove fill NA.
I think he
Okay.
wants to
Yeah.
see the modes.
Result.
Mode result.
Yes, yes.
Okay.
The inner part of that fill NA.
That's it.
Yes. Mode of, okay.
This is what you want to. Okay, you want to visualize it. Okay, it's fine.
Yes, yeah.
So now that's done. So now we have replaced mean, median, and mode. Okay, and now if we want to check the values that we saw earlier, whether we are having any null values or not, we can just simply just observe that we have order price, two rows in order price, 4 in delivery charge, and 4 in happy customer, and just see whether we have done the imputation correctly or not. So everything is correct. So 000 is what we are getting the sum of the null values. So we don't have any null values in the data as of now. So, and now if we want to find out whether what's the objective, what's the data type, basically to check whether the data type of the columns of that particular data is correct or not, we can simply just do check the D types. Basically, D types is a function which returns the data type of each and every column. Okay. So now what we can observe here is like order ID, customer ID, basically you won't do any sort of statistical checks in that as well. So I'll just simply, in order to verify everything, just simply return the dirty data and see what should be the data type. Okay, so as you can see, order ID, which is containing alphanumeric values, so its object is fine. Customer ID, same, it's fine. Date should be in date format, so this is not fine. So basically it is an object it is showing, so it is considering it as a string, so it should be converted. So that's our first thing. Nearest warehouse, okay, it's an object, it's fine. Shopping cart object, it's fine. Order price, again it says float 64, it's fine. Delivery charges, it says float 64, fine. Customer latitude, longitude, fine. Coupon discount is integer values, fine. Again, order total, it says object, it is not fine. Okay, so coming back to the question that somebody asked, I'm sorry, I don't know the name, but they were saying that the data is having some information which is like not valid, basically. So this could be an indication. As a data scientist, you should think like in this direction, that this could be an indication that there could be two problems. Either the column is simply considered by Python as a string, okay, so you need to convert that, or into an integer value or float, okay, whatever. So in this case it should be float 64. But it could be a case where like there are some alphanumeric values, or there could be cases in which you can see that there are some values which does not make sense in a numeric column. Okay, so we need to check that. Okay, season, again it's object, it's fine. Again, is expected delivery boolean true false, it's fine. And distance to warehouse is flow 64, it's fine. Again, review customer object is fine, and then happy customer is boolean is fine. Okay, so but what we have observed here is like there is an issue with the order total, and there is an issue with date column, and this is just a first observation. There could be multiple other checks that we can do as well, so that we'll see later. Okay, how comfortable you guys are in regular expression? Just wanted to check, are you guys very much familiar with regular expression, or are you guys having some issues with regular expression or things like that? Anyone can answer, like if they are happy with the usage of regular expression. Familiar, just familiar, can understand. Okay, cool. Okay, so first thing first, we observe that there is a problem with the date column. Okay, so let's just try to convert the date column into a date time format. So just have to use pandas to date time, and date column could be converted into date time format. Okay, Praveen, no worries. So we'll just do it. It throws a bit of warning, but it's fine. You can just ignore warnings as well. Okay, Google the code of ignoring the warning, and you'll be just fine. So it does not throw any error. It has just thrown some warning, and that should be fine. Now, if you just print the date time, the date of the data type of the date column, it says date time 64. And basically, if you want to check the data type of all the columns, again, you can see that it has been changed from object to date time. So initially it was object here. Now that we have converted it, it shows date time. Okay. Now we need to do some sanity checks as well. Okay. And before moving into that, I just want to inform that the sanity checks are basically very important to check the uniqueness in the data. Okay. So if at all the data is not unique, then obviously we need to replace that particular row with a unique value, or do some imputation, or just simply replace it. Depends. So right now, if I'm talking about this particular column order ID, if I run this code, either if it is having unique values, it will print that the order ID is unique. If it does not, then it will just print that the order ID is not unique. Right now, what we have seen is like order ID is unique. So this particular column is unique. So it's fine. Now, now that we have seen that date is fine, nearest warehouse is the next column. And I'm just doing it for one. You would want to, check all the columns. And this is just an example, just to give you a concept that you should perform these sanity checks on all the columns that are present with you. Okay. So if you do that, you see that although it should be an object data type, okay, nearest warehouse should be an object data type, and it's fine. There are some unique values which are coming like in this format. So Thompson, Nicholson, Bakers should be the three values that should come, but there are values like small n Nicholson, small t Thompson, Thompson 911, 1211 Bakers, Nick 123 Olson. So as you can see that it should be either Bakers, Thompson, and altogether this is particularly very wrong. Like it should not be Nick 123 Olson. Okay. So you'll get that information. If you want to verify, you should verify it with your business analyst or the stakeholder directly, whether this makes sense, 1211 makes sense, or 911 makes sense, or Nick 123 also should not make sense, but just double check whether it makes sense or not. Okay. So a lot of regular conversation regarding these data cleaning part also goes on, which is a part of the data science structure, or the day-to-day what we follow while doing the data cleaning as well. So if somebody asks that how did you get to know that whether this particular column is having this information and whether that information is viable or not, so just mention that we did a sanity check, we did an analysis and found out that these are particular categories that we are getting, and a lot of them were not making sense to us. So we wanted to double check whether they want to keep the data with capital N Nicholson, small n Nicholson, and like with Thompson and 911, 1211, there are some alphanumeric values and there are numeric values in an object column, which does not make sense to us. But if it makes sense to business, fine, we can consider it as unique values. If it doesn't, then we need to replace it. Considering now that these are not at all unique values and we need to do the operations on, and this answers the question of that particular doubt that whether if we are having data of this sort, like having numbers in an object column in a string where it does not make sense, then what we need to do. So first of all, it says that there are multiple unique values. Okay, it doesn't mean that this particular value Nick 123 Olson is repeated just one times or just are present multiple times. Okay, so we need to check first whether these are like present only once or present multiple times. It doesn't matter whether it's these particular values which are not making sense to us. These in particular these three values, if they are not making sense to us, are present once or multiple times. Okay, even if they are present once, then also we need to replace it with the same procedure. Even if they are present multiple times, then also we need to replace it with the same process. Okay, so now we need to check. So now if we do this, so what this regular expression is telling me that I'm defining a pattern here. This pattern says that in the string, wherever there is a digit, basically a number present, okay, in my nearest warehouse column, in that string, it contains a pattern, and this pattern is basically this. Okay, then find it out and present it to me. So okay, So in this particular variable named result, okay, those three rows have come up, which has like basically a string with numbers. Okay, so Thompson 911, 1211, Bakers, and Nick 123 also, they are all present once. Even if they are present multiple times, it doesn't matter. This particular pattern, this particular regular expression will find them out in this particular column and return the values. Okay, makes sense until this point?
Can you run that command, mask is equal to dirty data? Only that statement, individual, or print the value of mask. That will also work.
Yeah, I mean, it will work, but it will return the Boolean value, whether it's true or false. Okay, so yeah, so nearest warehouse, as you can see, there are three rows, and in this smaller data set, these three rows are basically returned because of the incorrect data. There could be multiple rows, and with the same sort of code, the same sort of concept, you can find out those impurities in the data and just replace it with nothing. Basically, I'm not replacing it with any spaces, I'm not replacing it with any value. I just don't want this 911, 1211, and 123 in between. Okay, so what I'll do is I'll just replace it, okay, with the same I'm taking the help of the same regular expression. You can see that the regular expression pattern here and here, when we were trying to find out is this the same, and when you compare this line of code, okay, it's just the same. Instead of contains, I'm just replacing that, and here I'm just replacing it with just two columns. Okay, and this particular thing does not have any space. If you give space, then obviously it will be replaced with space. I'm not giving any spaces, so it will just replace it with nothing. And you can see that when it is replaced with nothing, Nick Olson will come all together. 1211 spaces will be omitted, and Bakers will come in front, and obviously 911 will be replaced. So these are the things that you can get in a data which is not at all clean. Okay, and these are the three types. These are the three different cases which you can find out. That impurity can be in front of the information that you want. Impurity can be in between as well, and impurity can be at the end as well. Okay, in all those cases, you can just simply replace it using this regular expression, and what you can see is it has returned the data after doing the cleaning. If you want to double check what has happened, okay, I'm just running the same code over here that we used, just to double check whether they are being replaced or not. So now, right now, I'm just finding the same pattern in the data in the same column, nearest warehouse, and let's see, it is not returning anything. So there are no impurities left in this particular column. Okay, now this is an example. Okay, for one particular column, your task would be to find out whether it is present. First of all, you need to see whether a similar sort of pattern is present in other
Rahul,
column.
can we use instead of regular expression stop words?
Stop words.
Yeah, like import string in that stop words we can use. No, so similarly, like what regular expression is doing, same thing only. Stop
words you can use, but again, what I would suggest is, obviously you can use stop words, and that I would say regular expression is I mean, just one thing. I mean, one thing as basically would give an edge over stop words would be regular expression are faster. You can use obviously stop words, but regular expression are very, I mean, faster than any other operation. So it's very close to it's basically an extension to NumPy operation. So NumPy operations are very fast. So instead of stop words, I would still suggest I'll still go give an edge over to regular expression. So and rather than like breaking the string to different words and trying to take out as numbers as delimiters and
yeah,
them.
I got this, Rahul. Like another approach also we can try now. That is yeah.
It can, but I would suggest stick to regular expression in this case. Or if you find out a quicker method, then by all means you can go for it. Okay. Cool. Now let's see if we have something. Okay, so now it is replaced. Okay. Now, suppose we have an alphabet character basically, or special character in a particular column. So this could be another impurity that can be found. Okay. So you can simply, I mean, your homework would be to use this particular code, okay, to find out in every column. Okay. What I would do is I would show just an example that how, if at all, there is an alpha bet character, or basically a special character that has been inserted in a column which is having numerical values, and how we can replace it. So as you can see in order data, this particular thing, basically order total, okay, this is an numeric data type. It should be a numeric data type, but when you go over there, the order total is basically an object. Okay. So we need to replace it with the values which basically make sense. Okay. Now your work is to find out which are those particular values, just like I have found out in this case. So a little bit of task would be helpful to understand as well. I already know that which particular rows are present. Okay. So I'm just simply replacing it. Okay. Now your task would be to find out which rows are there. So before this code, before this line, I would suggest find out the rows having the impure data. Okay. Homework. And since we already know from the description of the data types that already the order total is object, and we need to like replace that with the uh, it gives an indication basically that we are having some impurities in the data, and we need to replace it with nothing basically, so that all the digits come together, and it should make sense that whether the object data type in this particular column uh, should be a numeric data type, but why it is showing object data type. So basically what we are trying to find out is whether that particular numeric data type is having an alphabet, or maybe a special character, or anything of that sort. Okay. Can we agree with you? Okay. Right. So what I'm trying to say here is basically I'm trying to replace, okay, I'm assuming that my object data type in the order total is incorrect, and that's because of the presence of some special characters. That's because of the presence of some alphanumeric values. Okay. Because of that, it should be only numeric column. Okay. Because the order total column basically is basically telling me that the order price and some coupon discount that has been applied and delivery charges all together make the order total, right? Okay. And that should make sense rather than a number which is having like alphabet values, alphanumeric values, or things like that. Okay. So you need to find out whether those are present or not. Okay. But I already know that these particular values are present in that particular column. Okay. Is sanity check in sanity check, is necessary to use loops? How it is useful? Depends. Like if you want to do a sanity check on the entire data altogether, you can use a loop on each and every column of the data, and then basically do the sanity check. But the more judicious way is to just look into the data type of that particular data from the data frame, and then do the sanity checks one by one. Gives you some level of satisfaction as well. I mean, for me particularly, if I do the sanity check for each and every column individually, that will give me more confidence that my data is clean, first of all. And I'm doing all the checks by making sure that every information is covered. So that's why. But it depends, solely depends on you. That's up to you. If you're happy with that, you can do that approach. Yeah. So now that we have, now we want to just replace it with the alphanumeric character. Okay. Then obviously you can do that. Or I'll just do it for you just to give you more clarity if you want to find out the pattern that what we are actually doing. But you should do it for your basically. Okay, so we are doing order total. Contains rejects this. Okay. 493 columns in this particular thing. Okay. So now if I'm trying to find out a pattern of alphanumeric or alphabet variable in the order total. Okay. And just replace it. This results. Just change the name as well. Okay. It shows that there are 493 rows. Okay. So this particular regular expression might or might not make sense. Okay. To some of you. And what it means is basically it is trying to find out all the alphanumeric values in the order total. So which means it is taking these dots also into consideration. So that's why it is returning all the values. Okay, all the values that are having float integer type basically. So dots. So that means it gives me an indication that there are basically kind of 7 rows out of 500 rows which are having basically only alphabet variables in alphabet values in that particular variable order total, which we are trying to figure out. Okay, so what I mean to say is basically if I'm trying to replace all the alphabets or special characters starting from A to Z or A to Z or anything, something of that sort, then it will just replace those alphabets with the with nothing. Basically, I'm just replacing this regular expression with nothing. Okay, in my order total column. If I do that, okay, there's some error that it is showing. And when I check the information, okay, it is showing a non-null. And if I do the order, if I check the order total, it is still saying that it is an object data type. Can anyone tell me why it is happening? Or do you want me to explain one more time? Just let me know.
It got replaced, but not change the. We didn't explicitly change these data type. No? If it is evenly clean, we need to cast it. The
Exactly.
float.
It is
So that
it is basically working on those values that has dot only, which is considered as alphanumeric, but they are not, and it is not touching those 7 or 8 values which are actually alphabets.
you both are partially correct. Okay, so we did not change the data type. Yep. Yes, Kedana. Yep. So you both are correct. Okay, so what is happening here is our objective is not to touch base those values which are having dots, because it's a float data type. Okay, so it is having some values before decimal point as well, and 2 values after decimal values as well. Okay, doesn't matter. Now it is just checking all the alphabets, but again it is also considering the special character as dot and trying to figure out whether it should be replaced or not. Okay, so now that's why when you do the data order total values, and you see that there are values which are present in this particular column, it has been those dots has been replaced as well. So as you can see, 11,059.89, which was previously there in the first row, 11,059.89, it has been replaced by nothing. So it has replaced 11,059.89 as well, and it has replaced those special characters or anything that was present as well. So what I'll do is I'll just show it to you guys that how it is basically working. Okay. Yeah. So now what you need to do is we need to run it to check all the values. So again, it answers the question of a particular doubt that whether if we are having like some alphabets in the numeric data type. So 229 AV SAV 58.58 116 RA RR20 and this particular value as well. So there's a upward sign and then basically and ampersand or things like that. So these are some of the values, I mean, just to check that are present, and it is not following any pattern. Okay, so it's not at all homogeneous. Okay, it's not at all following any pattern. That, and these are some examples. There could be multiple examples, okay, which are present, and basically you need to figure out a way to how to handle this. So this is one of the way in which you can handle it, but this works for integer value in the column which is having data type which is integer. Okay, now this is float, okay, with decimal, so it is considering dot as well. Okay, so this gives me an indication that we need to change the regular expression pattern. Okay, now keeping in mind that we want to replace these alphabets, say suppose SF, SAV @RR, or maybe this particular value like GG and these things, but we don't want to replace the decimal points because we want to keep it like this. Okay, so, and this particular bit is what it is doing, it is just replacing the entire alphanumeric characters and everything which is not a number. So we need to replace everything, okay, which is not a number, but we want to keep decimal points, decimal, to indicate that this is 6,934 rupees and 29 paise. Okay, not that it is like it will be not in a format where it will be converted into 6,93,429 rupees. Okay, because that information will be wrong. Do you understand what I'm trying to say? Any doubts in this one? Yes.
No,
No?
Rahul.
Okay, so this gives me an indication that this particular regular expression that what we have chosen to do is not correct. So what we need to do is we need to change the pattern of this regular expression. Okay, so let's see what we can do. So the objective is to replace all the alphabets and alphanumeric values, alphabet and special characters, and the objective is to keep the decimal, okay, because it is not considered as a wrong value in my string. Okay, so now what I'm trying to replace is everything which is not between the numbers 0 to 9, because that covers everything. Okay, 0 to 9. Okay, so for that we need to say that everything which is not 0 to 9, okay, should be replaced along with a dot. This is the regular expression which will solve my problem, basically. Do you guys agree to it? If you have some sort of information about regular expression, you would be understanding what I'm
Rahul, here we don't want to replace dot, right?
exactly.
Other than dot. Oh, correct.
Other than that, so this will replace 0 to 9 and dot, but this is anything but 0 to 9 and dot. Okay, this particular expression.
Cap symbol is not. It is not a expression. Cap symbol.
Yeah.
It is like a not in regular expression.
Anything but, yeah, that's what I'm trying to say. Anything but this. So this is not 0 to 9 and dot, but it will replace everything but 0 to 9 and dot. Okay. Okay.
If
now
it is two dots in any value,
then in that case you need to what you need to do is you need to find a pattern. Okay, then this particular bit is valid. Okay, first what we were doing, then what you need to do is you need to do a round. Okay, use a round expression and then just decimal it to last 2 digits. That's all. Okay, then it will convert it into considered as string, converted the last two decimal points, put a dot into it, and then do the data transformation. Make sense?
So Rahul, what was the use of W there in the regular expression slash
Okay.
W?
Slash W means that everything which is following an alphabet pattern, okay, that will give you the indication that basically A to Z is covering all the smaller this thing,
Alphabet.
so smaller alphabets, and A to Z is following the larger alphabet, and basically W is for any word character basically. So word character could be any special character, also anything which comes under, like when you see the keyboard of your laptop, right, from in the second row you can see before the backspace everything which comes under it.
Mhm.
It can be as word, and everything is basically covered under that. So any special character will be covered under that.
Okay. And can we use anything like which will exclude only dot in this command, like A to Z, and W, and addition of this we can use, like we are including dot here.
Yeah, you can do it, but then again it is making the regular expression much more complicated. Okay, so there are multiple ways to, there are multiple pattern that you can follow in a regular expression. So if you want to you can Google it, whether you want to replace just one dot or you don't want to replace the second dot, or if at all if the data is following a pattern. So again, it is somewhat related to stop words as well, whether because it is like following, it is trying to check a pattern in the data and then trying to replace the data as well. Okay, so same way, it cannot you cannot just simply define one particular pattern in a regular expression and then you try to solve it. So that's why it's better to eliminate those chances of getting errors basically. So instead of giving the values that can or cannot be possible, just replace it with the values which you want to keep, okay, excluding that. So right now I want to keep 0 to 9 and dot, and I want to exclude that, and whatever comes in between, in front, or wherever, it will be replaced with nothing. Okay, so
Got
this
it.
is much more easier approach. Okay,
Rahul, I
so
have
that
one question.
Yeah.
Like this total value column is basically the column which is not the user dependent column. This is basically getting reflected, I think, from the order count into price. Okay.
Yeah.
So in real world environment, there are very less chance that this will get such kind of error. Did you face anything like that before, that where the dependent column, which is the function of other columns, have some sort of error? Because data engineers put lots of constraint not to get input from the user in such a way so that data get
Yes. So this is just to give you an example. This order total can be easily can be easily be order price. Okay, and you just have to replace the name, the column name from order total to order price and check. So what I'm saying here is you need to find out the rows having the impure data. So since I have designed the entire thing, okay, I know where the impurities are lying, but your work is to find out this in every column. Okay, and basically this is just an example, and you can do it you can use these two regular expressions to check basically everything in the data as well. So this is just to inform you that you can use regular expression to check the sanity of the data, okay, to find out the impurities in the data and then try to replace it. Obviously this order total is not user dependent, and it can or cannot, I'm not saying that 100% it should be correct. Okay, it can or cannot, but many of the variables which are coming from user can have these sort of errors. Okay, and mostly in the industry where data engineers are not doing tremendous job, they would be having impurities in the data, and your job becomes to clean that data, and these regular expression help. Okay, makes sense? It's just an
Got it.
example. Okay, so now what we need to do is we need to run this code. Okay, it will throw some error, that's fine. Now when you get the info, it will say that again the order total is object, because we haven't changed the object type, sorry, data type. Okay, but now if we want to find out the values, It has replaced those alphabet characters. Somewhere here we were finding out RRGG. These are not present. So you can just simply check it. It is not present. Okay. If you want, you can take the sum of this particular as well. So if we want to take sum, it will give you, okay, it's not changed into data type. The data type is not changed, so it will not throw you the sum. So again, we need to change the data type of it as well. So you all know, you might be knowing that you can use as type to change the data type function as well. So what I'll do is I will just simply copy paste everything here, and instead of this, as type float 64. Okay, now this has changed to float 64. Now if you take the sum, it is giving me the sum. So that means that if a mathematical operation has been performed, then the data is fine. Okay, and what we are getting here is the decimal values that we want, so that is also fine. Okay, make sense?
Yes, sir.
Okay, now if you want to just check everything is in order. So it is giving me 11059.89 and everything. It's present in my data frame as well, in the .data. Cool. Now let's see. When we were seeing, now we have to take care, make notes of everything, that what we were seeing is making sense or not. So Thomson, capital T, Thomson with small t, capital N Nicholson, small n Nicholson, Bakers. Okay, there's no small b Bakers. It's fine. But Thomson and Nicholson are present twice, which essentially means the same warehouse names, but they are considered as unique values. Okay, by our Python programming language. So what we need to do is basically we need to check with the business analyst or stakeholder that whether they want to keep it like this or whether they want to change it. Okay, suppose they said that no, it doesn't make sense, the warehouse names is unique, so it doesn't matter whether small n comes first or larger n comes first. Okay, so what, or even though if suppose there's a presence of like Thomson with capital P in between, Nicholson with capital O or K in between, doesn't make sense. Okay, it will all be the same. So this particular concept or this particular code gives me unique values. So now if I check the unique values, since we have replaced the Thomson and Nicholson and things like that, so there the numbers 1 2 3 or 9 1 1 1 2 1 1, those were coming which are not present now, so those have been handled. Now we still are having these capital T, capital N, cap small n, cap small t. So what we need to do is we need to make them unique. So we need to convert these values into the same names. Okay, so when I'm doing it, what I'm trying to do here is I'm trying to do on that nearest warehouse column. Okay, and what I'm trying to do is I'm trying to convert it into string with the title. So this title function, what it does is it will always just in the backend, what it does is it takes the value of each string. Okay, converts the first letter into capital. Okay, just like a title. Okay, and then all the other letters into a lowercase. So the first letter would be uppercase and the other would be lowercase. Okay, so this means we have converted.
We can give 2 underscore lower also. No.
Yeah, you can do, but this is a much easier approach anyways. So I mean, you can do lowercase and uppercase. I mean, it's up to you. I mean, it depends on the business requirement. Right now, what it is saying that this Nicholson and this Nicholson is same, this Thompson and this Thompson same. So it's better to keep it as a title so that it makes sense that yeah, this is a particular name. And since we don't have any small b bakers as well, there's no need to change this particular bit as well. So if you're doing lowercase, you need to do it lowercase for every bit. If you're doing uppercase, you should do for every bit, but we don't need to change this bit because bakers is unique anyways. So it's better to follow a pattern which is with a data value which is already correct. Okay. So now we need to check the unique values now that we have changed it. So now there are only 3 warehouses named Thomson, Nicholson, Baker. So it's a journey from 5 different, where I went, sorry. Yeah, it's a journey from 3, 4, 5, 8 different data unique values to 3 different, because that was the objective. So this is the cleaned nearest warehouse column right now for us. And you need to check for those columns which are having these names and which can be used in future for your data analysis. So that also you need to take care. Okay. And finally, when you check that what are the value counts of each of the unique values, and you want to get a print out of it, get the values as well. So you can see that there are 197 warehouses for Thomson, 184 for Nicholson, and 119 for Bakers. Okay. So now this makes sense. If you do it without cleaning, then it will give you wrong information. That's what I'm trying to say here. It will say some other value for Thomson, some other value for Nicholson, small n Nicholson, small t Thomson, and again, some other value for Nicol 1, 2, 3, whatever we were getting. So that's why it's important to clean the data. And it basically covers 70 to 80% of data cleaning part, which are encountered in real world data. Okay, so where it's a mix of data, there's no non-homogeneous data, and where there's a mix of data with string, there's a mix of data with with alphabets, with alphanumeric values, with basically special characters. Everything can be sorted out with the use of these regular expression. And obviously you would say that this is for a smaller example and smaller data, but the same thing can be done for a larger example or larger data as well. Okay. So does it make sense, or do you have any other case which you want to cover as of now?
Yeah, no, this is a good example you have taken for us. So it will be helpful for us.
Yep, hopefully. Yeah.
And one more thing, like if we are getting these CSV files or data in a regular interval, and if we have done analysis for the few files or for the few data, then we can do the automate for these field as well.
Yeah,
because
obviously.
like the data type need to be converted to date time, or if we are converting any values, then we can use in the pt.csv also. There we have option like parse date, converters. So in the beginning, we are loading the data, we can handle all the things.
Exactly. That's what data cleaning is all about. Okay, you have to figure out the way to to clean the data in such a way that it makes sense. Okay, so now right now these Thomson, Nicholson, Bakers, it's all making sense. Now when you take the count of it, it makes sense that these 3 are unique values, and these 3 warehouses are the number of warehouses that are present for our customer are these many. Okay, so that's the thing. Now it's just about showing some insights using some charts. So basically what I'm trying to do is I'm doing the same thing. 197 is for my Thomson, Nicholson 184, and Baker's is smaller, so 119. Okay. If you want to take out the percentage value of these as well, you can do it by taking, so if the client is interested to know what percentage my warehouses, 3 different warehouses cover, so you can use this pie chart to do that. Okay, so you just need to do the labels, and then explode basically helps you to break that data, and basically then obviously the title, and you just need to show it, and obviously it will come out. Okay, same goes for bar chart. RGB defines the color. Rotation is one, you can do the rotation as well. Figure size, basically you can change the figure size accordingly, and it's just taking the count as y in Y label and giving you the title and the x-axis. Okay, so this is a little bit about the information that you can present to your client as well after doing the data cleaning, but it is not possible to do it without data cleaning. Okay, now coming to the very last bits of what we are trying to analyze is basically we not only when we do data cleaning, obviously we check the data type, we check the null values, we check the outliers, we check the presence of string in the data, we check the presence of special characters in a numeric data type, we check the presence of alphanumeric, alphabet, everything. And it will all be, it can all be checked and covered under this section before we go on to the next one. The next bit is, once you are happy with the data, the information that you have got, okay, one final thing that you would want to check is basically whether the calculation that has been performed in your data are correct or not. Okay, so right now we are analyzing order price and order total. Okay, the order price says the price before any discount, delivery charges, and order total says price after all discounts and or after delivery charges are applied. Okay, so when you go back to the, or maybe it's better to show it in Excel. When you see this data, the order price is nothing but for each and every order, whatever the order price would be. And if a coupon discount is applied, suppose 10%, 12,200 into 10%, whatever should be negated, and then delivery charges should be added. Okay, but this information can or cannot be correct. Okay, now you can do a simple sanity check whether this particular bit is correct or not. Okay, so let's see. We find a maximum value in the order price. So this is, maximum value is 9,47,691, which we were getting probably would be an outlier, and minimum value is 585. Okay, so this just to give you the information that whatever changes that we have made has not affected the order price. Fine, simple sanity check that we have done. Now let's just check the calculation. So when I'm trying to check the calculation, what I'm trying to do is I'm using the log function to find out the first 10 values to see, and only the calculation part. So right now I'm only interested in order price, delivery charges, coupon discount, and order total, because this is the calculation part of my data. Okay, now you can do the same thing if there are multiple calculations involved in your data. Okay, it's just that I want to give you one example. Obviously, when you go into the industry, everything cannot be covered in 2 hours or 3 hours of lecture. So obviously, this will cover 70 to 80% of what you need to perform in the industry. Obviously, 10 to 20% gap would be there when you will experience new data. You will get to know that, okay, regular expression, this particular pattern of regular expression will not work. Something else we need to do. This particular calculation is different, so we need to do something else. Okay. What's this Google Drive, Yash? Sorry.
Like Afsan used to update our notebook.
Okay, to give you the, I mean, this notebook, I should insert this note, upload this notebook into this drive, you want to say? Sorry, I'll just double check what exactly it is. AI topics. Okay, fine. Okay, so let's just check whether the calculation has been correct or not. So if you just do a simple calculation, 12,200 multiplied by 10, okay, so that will give you like 1220 something, and that should be negated. So, and 79 rupees and 89 pence should be added. Okay, so this calculation somewhat looks to be fine, could be wrong, fine. Just to do a simple sanity check. Now when we do 9,080 and do, if it is a calculation that has been done, the coupon discount is 0%. Okay, so that should be somewhat, I mean, if we do a calculation like multiplied by 0, then everything would be 0. So if we negate it with 0, it's fine. If you do 10,060, 10% discount, this does not look correct, because now it is giving you a value which is like 9,668, which should not be the case, because it is somewhat not making sense to me. Again, even if I'm doing 15% on 24,800, again 21,137 is not correct. So maybe there's a calculation mistake. Okay, if it is there, it's fine. If at all it is not there, then also it's fine. I am having a doubt whether the calculation is correct or not. Okay, so now there are two scenarios in it. There could be any number in the coupon discount. There could not be any number in the coupon discount. Now, again, one checkpoint is that I am considering that you have checked whether in the coupon discount column, okay, the sum is coming out to be correct, okay, or average, or whatever you feel like should be the correct method to find out whether it is a numeric data type and it's not having any special characters. So I'm assuming that you have done that check, and I'm assuming that this particular column is fine, is free of impurities. Okay. Is there any way we can do the data arrangement during the data cleaning? What do you mean by data arrangement, Saurabh?
So basically, if we receive any data and there's a disorder of the data, like suppose the customer ID is in the separate, in the different column, and there's completely, I mean, and the order like is another column. So do you before starting the data cleaning, or we can, or during the data cleaning, can we order in the proper way so we can proceed further? We can check the next point, like for the values and the names kind of thing. Are you getting
See,
the point?
yeah, I got your point. So if your objective is to design a machine learning model, okay, ultimately, it doesn't matter the order, okay? So your machine learning model will pick up all the important variables anyways and try to find out a pattern in the data. So that's another thing. Okay, Praveen, yeah, it can, what I'm saying is it can or cannot be correct. So it's fine, okay? My objective is, like, if I'm having some doubts whether it is correct or not. So in this case, particularly, if at all it is wrong, we can handle that, okay? So, okay, so
So
coming
if
back
we
to
have more features, we can use feature extraction techniques also, no, Rahul?
feature extraction techniques, okay? So
Yeah,
feature
like
extraction,
RFE.
yeah, feature extraction will come into picture when you are trying to, so suppose RFE, if you're trying to design a model, like RFM model or something like that, then your
Like
recency.
when we can apply that, before, after EDA, or before standard scalar?
Oh, no, after EDA, you can apply. And obviously, if you scale it, then it will not get the exact value that you want. Especially, I'm talking about in the case of RFM. Okay.
Okay.
It depends again on multiple factors. But if if you're talking especially in case of RFM, then recency of the order, frequency of the order, and the monetary value of the order matters a lot in that case for a retail company. Then in that case, if you're trying to generate an RFM variable, then obviously you need to.
No, I'm talking about RFE, like feature extraction.
Okay, sorry.
RFM is used for k-mean, like that
No,
is
it's
for
not.
recommendation.
Not every time for recommendation, but yeah, it's fine. But yeah, RFP, yeah, obviously you need to do data cleaning first, then only you can perform feature extraction. That is also subjective because you do feature extraction considering that your present data, what you already have, is not good enough, and you need more features to enhance uh, uh, your prediction, to improve your prediction, to support your Y variable, okay, your dependent variable. So that depends, but obviously you should do after data cleaning, not before. Yeah. So that being said, okay. Coming back to Saurabh's question. Sorry, you were interrupted. Sorry, Saurabh. So yeah, is there a way to do data cleaning, data arrangement? So yeah, obviously you can do data arrangement by using log functions. Like you can check the index value of the column and you can rearrange that. Okay, just do a simple Google search. You will be able to find out. But that is not our objective. We can simply take that out. So I'm using a log function here as well. Just taking it out, taking the variable values, or you can just simply take the index values of that particular column as well. I don't want to count the index numbers, so that's why I've taken the variable names, and then I'm just checking the first 10 records whether the calculation that I see is correct or not. Okay, might be correct, might not be correct, I might be wrong. Okay, so let's just do a check whether it is a valid calculation or not. Okay, so if I'm having doubt, so let's just do it. Okay, so first 10 records, I'm doing it for the first 10 records. What I'm trying to find out is The concept says in the document, in the BRD, you will see that the calculation, the formula was provided to you, that order price multiplied by the coupon discount, whatever value will come, will be negated from the order price, and this delivery charge will be added. So what I'm trying to say is, like, can you see the chat on this page as well? Can anyone give me an answer? Like, can you see the chat page as well?
Yes.
Okay, good. So somewhere somebody gave the calculation as well. Where was it? Sorry. That might have been disappeared. Sorry. So what I'm trying to do is the formula here is the order price.
Yeah, Rahul, I erased it. Actually, I have given that now.
Okay, no worries. That's fine. I'm just this will make much more sense. Order price multiplied by coupon discount. Okay. So what I'm trying to do is I'm applying a coupon discount on my order price, and I'm just summing the delivery charges. So this would be my formula. Okay.
That
Will be equal
discount is not in
to
percentage.
So we
Yes.
divide by 100 is
Yeah.
what?
Thank you. Okay. So this would be my final formula, which says my order price minus the discount percentage that we have got plus the delivery charges will be my final price. Okay. This is the formula that we will follow. Okay. Now what it says is coupon discount. I'm just using an if-else formula. You can use simply any other format as well if you feel comfortable. So I'm using an enumerate function. If you know enumerate, if you have studied a bit of Python, then you might be knowing what enumerate does. It basically tries to give you each and every
Indexes with the iteration format.
Yes, it gives you each and every index and it iterates from the first value to the last. And if I'm giving you the range of 0 to 10, then obviously it will follow the first 10 records. Okay. So if my coupon discount is not equal to 0, okay, then what it will do is discount price will take the order price from first row, and then it will do the calculation. So it will just take the order price from the first row, and it will take the coupon discount from the first row, multiply it, divide by 100, which gives me the percentage value, and would be discounted price. Okay. Now my price will be discounted price plus the delivery charges from the first row. I value will give me the first row of the index, and then I'm just final price is like I'm just rounding it to two decimal points. Okay. So that would be my final price. Else, if at all this value is equal to 0, okay, then it will simply just get the order price and just add it with the delivery charges, and that would be final price rounded to 2 decimal points. Okay, make sense? Now that it is done, let's compare the values. Okay, it should not be 11059, it should be 10980, which is wrong. 914271, 94271 is correct. 9603, again 9668. So there was some error in the data, which we have picked out by checking the first 10 records, and now we have resolved it. Now there could be issues in the entire data, okay, in the calculation, and I don't want to take risk. I just want to.
Rahul,
And I,
sorry to
yes,
interrupt you. Something wrong. It seems something wrong there. 9668 should come in your second index. That should match what I feel. 9668 9668.7 dot 87. It should match with your output.
Okay, let's see.
In formula, maybe.
Maybe. Let's see. Coupon discount.
I think it's 10%.
Delivery charge is 65.87. Yeah. $9,668.87. Okay. Let's see. So this is giving me multiplication of coupon discount divided by 100. Okay, there's a mistake. I need to do this and this, and then 9603, 96687. Still not giving me. So this is there multiplied by this and divide by this. Discount price plus 30 data every time. Probably. Probably this is not trying to do. So I'm getting the first value and negating it with the first value of the order price multiplied by this, divide by this. And then I'm adding it with the delivery data. Or
Now, can you copy this whole entire formula and can you paste it in the chat?
Yep. Just a minute.
Check it. Yes.
Yeah, sure. Let's see. Final discount price. Oh, okay. Okay, I got the issue. Anyway, but yeah, this now this should be fine. Okay. Let me just do it. What I'm doing is discount price, but it is not adding with the, here is the mistake. There's no problem with this. There's no problem with this. This is, and this is here, convert, closing, opening, closing, closing, and finally this. Yep. So it was just simple, like when I was doing the formula, I wanted to make it a bit, I wanted to break it down. So instead of discount price, I just put a discount price. So that's why the error was coming.
Yes.
Okay. So now the values match 9668.87. Okay, fine. Thank you for pointing out this mistake. And I might done the same thing here or not. Let's see. Yeah, here as well. Okay, so yeah. So now that the calculation is correct, now we can now we have checked it for the first 10. Statement block is on. Okay, now that the calculation is correct for the first 10 rows, now we can do the same thing on the entire data. So now right now I'm not taking the range from 0 to 10. Now what I'm doing is I'm trying to take the length of the entire column, okay, order price in the dirty data. And then I'm doing the same operation, following the same formula and rounding it to the to the 2 decimal point of the price data in the price variable. Okay. And now let's just check. Now, again, it's not viable to check all the information. So we need to just check that this formula has been applied on the first 500 on the entire data or not. So if this particular uh, entire piece of code works, then obviously it will come into the price column. Okay, and the price will be having the length of entire 500 rows. Okay, so that's what it is coming. Okay, so I'm just applying the simply in a nutshell, I'm just applying the entire formula of the with the condition whether it's not equal to 0 or equal to 0 on the entire column name coupon, the entire column name order price. Okay, and then if we check the length of that list where we have applied, so it has been applied to the entire 500 rows. Okay, now if you want to check the dirty data that we have, the values will change. 11059 should be fine, everything else is fine, but some of the values will might have changed. Okay, 5970 130.
What we can do here, Rahul, that those calculated values and the value which is present here, if both are matching, we will be skipping and we can print those which are differ, so that we can easily get to know those records which does not match with the correct values, right?
Yeah, I mean, you can do that, or you can do what you can do is you can create another column. Okay, so suppose
Yes.
this is present in final price, just create another column, add that add that column in this particular data frame, and then compare it, and then add another column to check if the values were correct or not. So that flagging you might you can do. So that's up to you basically. Okay?
Yes, sir.
The way is to just take the sum before performing this operation and take the sum after performing this operation, and just to see whether that makes sense or not. Okay, that would be the easiest approach.
Got it. Thank you.
Okay. So before doing this calculation check, take the sum of the entire order total column, and after doing the calculation check, take the sum of the entire order total column, just to make sure whether your calculation is correct or not. So again, this is a part of data cleaning where you have to check the calculations if are there or not, apart from the other things that we have discussed, right? Final thing would be to do an outlier check on values. Okay, so if I'm doing the data check, I'm just, and in order to do that, you need to convert that entire column into a series. Okay, so that you can calculate the quantile. So you might be aware of lower quantile or quartile or upper quartile. Okay, and you can see that the lower quartile is 6388, the upper quartile is 17,926 for the order total column. And then basically, if you want to find out the interquartile range, you just need to negate the quartile 3 with the quartile 1, and you find the interquartile range. Now, if you want to find out the lower limit and the upper limit of the data, it should be minus 1,000, 10,919 and 35,234. But again, it says that there should be some outliers, because we were seeing that in this particular column, there were some values which were coming extremely high. Okay, so when we saw the minimum and maximum value, where exactly it is, yep. So order total was 9,266 for the maximum value, and the order total, did we do it for order price? Okay, so you need to do just check the code and see the max and minimum value here before even assuming that there are outliers present. And just do order total. So as you can see, the order total is 85,000, 8,53,012. Okay, that's the max value. And if you want to check the minimum value, then you can see that the minimum value is order total 530.34. So as you can see, the upper limit is minus 10,919, Lower limit is minus 10,919 and upper limit is 35,234. Then that means there are outliers which are present. Okay. And what we need to do is we need to find them out and take them off. Okay. So in this particular bit, what we are trying to do is we can do with box plot easily. Yes, Rupesh, we can do with box plot easily, but box plot will just give you, and we did that initially as well. This is just giving you an indication. Box plot always gives you an indication of the presence of outliers. Obviously, it gives you a range of values as well. But with the interquartile range, you would be able to pinpoint on those numbers, and then it's easier to replace them as well. Okay, so now if you do it, so you can see that the count of these are the outliers which are present. So there are 18 records which are outliers considered in this particular data. So out of 500 records that we have 18 records in the order total column which are outliers. Okay, now I'm removing the outliers. What you can do is you can simply replace it with median value if business allows. If not, you can just take it out in a separate data frame and then do a calculation check, do a pattern analysis on that, on top of that as well. We never just simply remove the outliers and leave them to be stranded. Okay, so every single time when you will go into the industry, when you're saying that we handled the outliers, this doesn't mean that you remove the outliers. Okay, if there are millions of records and if you have to remove these 18 records, then it's fine. Okay, then in those cases also it's fine. Then also the customer would be interested to know that what was the prediction for these outliers. Okay, so you have to run the machine learning algorithm for these outliers altogether separately. And there could be cases where these outliers themselves are following pattern, and you might have to redesign your existing algorithm or design another algorithm to find out the prediction for those outliers altogether and then sum up the results. Okay, but in this case, I'm just simply removing the outliers. Okay, because we're not going to discuss the machine learning algorithms to handle outliers. But these are the cases if interviewer asks, they will definitely not ask you to perform that on top of in the interview itself. So your answer should be like this. So if we have encountered outliers, if there are few numbers of outliers, then we basically remove it from the processing in machine learning algorithms. And then we either do, if there are small number of outliers, then we either do a manual calculation for it and then give the prediction altogether. Or if the percentage is like more than 5%, 10% or 15% in the data, then we take the outliers out of the context, and then we do the data analysis for those outliers altogether separately. And if those outliers follow a pattern, then we design a separate machine learning algorithm or tweak the existing machine learning algorithm for the prediction of those outliers, and finally take the sum of the non-outlier data and outlier data and present it in the final report to the client. Okay, that should be your answer. Any confusion in this?
Rahul, we can also replace the outlier with the help of IQR.
You can, but again, it depends, Rupesh. So if you, sorry.
Yeah, if you remove the outlier, means still some noise will be there. No, if you exclude that one, so it won't give the better performance.
If we,
like you said that scenario based, like 5% or 10%, 15%, or else we can exclude that part, outlier part alone.
Yeah. So that's the thing. We can exclude the outlier part alone. So in the main data, obviously outliers are outliers because there are a small number of values which are following the extreme values, and those are extreme values. So obviously you don't want your machine learning algorithm to get confused, right? So you do the prediction of those number of rows which are normal, which are in normal distribution curve. Okay, those who exceed that normal distribution curve length limit, then obviously you need to do a separate analysis whether they are themselves following a pattern. So sometimes what you will do is you will see a normal distribution curve like this, and then another small distribution curve like this. That means that in this particular normal distribution, main normal distribution curve, it is not following, it is following a pattern separately, and then there is another normal distribution curve for outliers which are following a pattern separately, if you draw that. Okay.
Yeah. At the
So
time
in
we can use anomaly detection.
you can do anomaly detection, but again, it depends. So when you're doing anomaly detection, if at all it is following a pattern, it's fine, it could be fine. But again, if it is not following any pattern, then I mean, you can get multiple different sort of small patterns in that when you do that analysis. So it depends on the data solely. You can do anomaly detection for your satisfaction. That's what I want to say.
Okay, Rahul. Thank you.
Yes.
Rahul, can you update this file as well as CSV file so that we'll try our
Yeah,
side.
yeah, I will upload, and you can try some new things as well on your own. That's fine. Okay. But yeah, as I said, this covers 70 to 80% of the data, good enough to clear an interview. Okay. Again, now data, now I'm just removing the outliers, and you can see that there were 18 records which were having outliers. Now those 18 records are removed. So 482 records. If you want to check the data without outliers, this is the data without outlier. Now data without outlier, and now the final outcome that we wanted to see is the objective was to perform EDA to find out how many customers are actually satisfied with the products and services provided by a retail company. So now we want to find out the true and false count. So now that we have cleaned the data, and now that we have removed the outliers, now it gives us much more confidence to say that, okay, not out of 500 records, but out of 482 records, we can say that the customers are satisfied and how many customers are satisfied or not. So there are 345 customers out of this 482 records, which says true, and 137 says false. So 345 are how happy customers, 135 are non-happy customers. And finally, if you want to present it, then simply you can either present it numerically or through pie chart, basically saying that okay, so around 345 customers are satisfied, 137 are not satisfied. That covers that 71.6% of customers are basically happy with the customer service. So if they want to control their business, they have to figure out how to make these 28% non-satisfied customers happy as well. So then they won't bother about these customers because they are happy with our services and products. They will keep buying it whenever they need, but we need to figure out how to improve their business with this zone. So that's the ultimate outcome. And this is a small example, but this simple analysis can save millions of dollars to for a retail company, which is like a growing company and trying to make some money by trying to improve their products and services. So that's the thing. So that's what I wanted to convey, that you can achieve these many things by just doing the data cleaning and finally give this report to your stakeholder or client. This can have, and this can also help in churn based cases. Yes, Rupesh, you're correct. You can use it in churn based cases as well. Yeah. So that being said, our time is almost up as well. And if you have any
what is meant by churn based use case, Rahul?
Sorry.
Churn based use case, you said, no? So
Yeah.
I didn't get that.
Yeah, Rupesh mentioned churn based. So churn based is basically a binomial outcome that we want to say. So suppose churn based example, best example on churn based, like HR wants to find out whether in near future, how many employees are going to leave the company or not. So that's churn based. Yes, selected or deselected, or leaving or not leaving, going to be a potential customer or not going to be a potential customer, things like that. They all come under churn based cases. Okay.
Rahul, one request, like this is the data set. We will try that part. If you are able to share some data set that is not clean, where we have to do all the things,
See, Rupesh,
then
no, the thing is, even if the data is not clean, I understand that this data is much cleaner, but this covers almost 80% of the cases, Rupesh, honestly. And these are the cases that you will face in the industry as well. Okay. So even if the data is small and it's pretty much clean, don't undermine it because it is covering all the cases. So if you follow the same pattern in each and every column, or maybe design a loop to find out each and every column, if you're not if you don't want to do it in a manual pattern for your satisfaction, then obviously you can just write down this particular bit in a loop, and it can do the entire analysis altogether. But uh, it will cover 80% of the problems that usually in a numeric data type or data type which is having this type of variable, which is a combination of object, date, float, integer, boolean, everything. So it is a very good example of the coverage of all the data types that we have. It's a very good example of the problems that the data can face. Maybe it's a string and it is having numbers. Maybe it's a number having alphabets or special characters and things like that. So it covers everything. Okay, so don't have to worry about that if you're missing out on something. It's just that a smaller data to perform calculations quickly, that's all. But even if it's a larger data, even it's unclean, then also you'll face the similar sort of problem.
okay. And the
You
feature
can
engineering
find
part
some
we will cover later.
feature engineering part. I'll cover it in maybe a project class or something. I'll have to check whether they want another EDA class for you guys, or whether they want to do a project class. I'm not sure yet. What I was conveyed is like take an EDA class so that people are very confused in EDA.
Rahul, it will be very helpful for us. Like if you come up with a new data set which can have like, I agree that this process is like enough for the what you have thought. But
Yes.
like if we are having 20 to 30% of the missing data, then the scenario will be different, right? We'll be following different methods, not the mean, median, and mode.
Sorry, I didn't get your name. Sorry. What's your name?
Akshay.
Akshay. Yeah. Your query is correct. The approach can be different. A mean, median, you can replace even if it is like 20-30%. Okay. Not with median. In that case, you remove the outliers and then take the average, and then you can replace again. In some cases, you will find out that these three columns, okay, so suppose nearest warehouse, shopping cart, order price, everything is not present. Okay, so this does not make sense. So it depends on the business analyst as well. So you have to think as a business analyst as well, whether it's making sense to the business. If my data has an order ID, customer ID, but does not have information about warehouse, does not have information of what is present in the shop cart, and does not have information about the order price, then that particular row is null and valid for me. Okay, so in a case where like one particular column is having missing values, you can replace even the 20% of the data as well. Either then I discussed those three pattern as well. So either you have to find out the previous and the next value, either you have to replace it with mean or median value, or either you have after checking outliers, and either you'll have to see if it is following a pattern, maybe a cyclic pattern, seasonal pattern, things like that. Okay, so
But
that's
if
the thing.
one more question. If the data is like highly missing, like 20 to 30%, and if we are replacing with mean, then is there chances that we are generating outliers? As
No,
most
if it mean you're not generating outliers, obviously not.
because
Not at
like
all.
when we are replacing with mean, most of the data will be around the mean, like the central value, and those values which were actually the maximum values now will be considered as the outliers, right?
So if there is a maximum value which is already present in the data, then only it will be considered as outlier. If that value itself is not present, then how can you say that it is an outlier or not? You cannot, right? So the best way to replace it with an average value. So suppose I'll give you an example. Okay. So suppose there are 20 people in your class, and the value of like 10 people in your class, that the average height of them is like 5'6". Like you will assume that most of the people, you belong to the same region, same community or something like that, then you will assume that the average height would be 5'6". If you consider the example that people in India the average height of men is like 5'5". Do you think that everybody is like 5'5"? No, right? But that's an average value. Okay, that's the safest value to go to and say in upfront that yeah, I can assume that with some level of confidence that yeah, the average height is 5'5" of the entire country. But that's not true, right? So nothing is true here. We're just trying to make it as accurate as possible. That's what imputation means.
Okay.
Rahul, how can we handle the imbalanced data set?
Imbalanced data set, so again, I use the word depends, but again, Rupesh, it actually depends. So when you have like imbalanced data, which is like 60 to 40%, okay, then simply replace it with simply just repeat those values which are having lesser amount, okay, and make it 50-50. If it is like 70-30, 80-20, something like that, then use random forest. It will just remove the presence of, like, it will take the random values altogether, and it will like, I won't say omit, it will minimize the chances of those imbalance in the data anyways.
No, this is not related to missing values. Like the data set is imbalanced. Maybe
I'm
input
saying about
variables are.
imbalance only. I'm talking about imbalance only.
Okay.
So suppose this is true false, right? So
Also
this is-
independent input columns, both for both cases.
yeah. So this is true false, and it depends, like if like 70-30%. Right now we are not doing any machine learning algorithm on top of it, but this is also imbalanced data only, right? So
Correct.
if you want to find out, so suppose you're training your model with the 80% or so 400 data is you're using for training the model, and 400 records you're using for testing it, suppose, then what do you think? This is a huge gap. So like you can do the balancing by adding more data in the not satisfied section as well, and then make your machine learning model learn as well. But simplest way is to like find out those algorithms which do not which are not susceptible to these imbalanced data. So random forest could be one that will do the cooking method. Okay, makes
And
sense.
yeah, that makes sense. And also like when we are collecting the data, so sometimes we ask for the more data, correct? So when we have that kind of situation, when we ask for the more data,
there could be multiple cases, Rupesh, honestly. One thing that I would give you the best example is like when you don't have a data in which like the variables, the independent variables are very supportive towards your dependent variable. So suppose you're getting the correlation less than 20%, less than 10%, things like that. Then you ask for more data in terms of volume and in terms of new feature extraction as well. So new features you want to add in terms of like getting a variable which will be helpful as an independent variable to your dependent variable. That's one example. The other example is like you're not your model is not robust enough. So suppose there are maybe you're training your model with 10,000 rows, and you're predicting it for 1,000 rows, but again your model is too heavy to handle this small amount of data. Okay, so suppose you're designing a deep learning model because all the machine learning models have failed, and now you want to analyze it deeper. Each and every neural network will come into picture, will try to learn from your data and then give you a prediction. Okay, in that case all your machine learning models have failed. Okay, it's not giving the accuracy that you want to get, and 10,000 rows of data is not enough, so you need more data. In that case, when you're trying to design a high level AI solution. Okay, in those cases also. But this could be two examples where like you either want to find out new features, or either you want to increase the volume of the data.
so it will depend on the accuracy score as well.
Yes, it will depend. So if so it all involves cost, Rupesh, right? I mean, people who are employing you, people who are paying for your cloud services, people who are paying for your for the entire team who's running behind everything, it all involves cost, right? So if they're getting results in 10,000 rows of data, And if they are happy with it, then why would you bother and why would they bother, right? If they are not happy, then the question of like increasing the data volume or increasing the variables will come into picture, because that increases the computation cost as well, right? So every time your cloud, even for a minute, if it runs extra, then that involves an extra cost for the company, right? And if it is running on a weekly basis to get the prediction on a weekly basis, then it can go up to thousands of dollars every time.
Okay, okay. And is there any criteria that there should be any minimum amount of data present for EDF process start or machine
There
learning?
is no minimum criteria, honestly. You can do a machine learning algorithm on this 500 rows as well. You can simply design a linear regression model, and and obviously it will not be enough for a deep learning model. Okay, so there's no minimum criteria at all.
Okay, okay, Rahul.
But there is a minimum criteria for time series algorithms. Okay, there should be at least 8 data points, 8 to 20 data points present. Best time series algorithms work with at least 20 data points present. Okay, if it is more than 20, it will work very, very nicely. If it is like less than 20, it won't work pretty nicely. So that's there. Same goes on for KNN algorithm as well. So if there are like more than 10 to 12 data points present, then it works fine. If it is less than 10, it might not work fine, because it is, again, the algorithm, mathematics of that algorithm says that it is trying to find out a central point, a mean value, which will, try to find the minimum distance with itself from the central value to the other data point. So there should be some data point present where it would be able to, properly do the calculation and take an average of it. So it depends on the algorithm, but there's no hard and fast rule.